Okay, now we're going to take a look at a new quantity called impulse, and it really has two definitions that you need to know about. On the left side in this box we have impulse equals force times time, and the equation down here says impulse equals Ft. So that's one definition. The other side is impulse equals change in momentum. Change in momentum. So impulse is equal to m delta v, just like it was on that previous slide. And because they're both impulse, you can set them equal to each other. So the F times the T is equal to the m times the delta v, m times change in velocity. So force times time equals mass times change in velocity. And so just like momentum has a strange letter, impulse is J. Nobody knows why it's J, that's just what we call it. So in this whole equation here, J is equal to F times T equals m delta v. Impulse equals force times time, also equals mass times change in velocity. The unit is Newton seconds or kilogram meters per second. These two are actually the same unit. Alright, so why is it important to have this quantity impulse? Well, we're going to talk about two examples where we maximize or minimize the effect of a force. So the first example has to do with sports, where you maximize the effect of force, and the second example is about safety in an automobile crash, where you try to minimize the effect of a force. So let's look about the example for sports. Usually in sports, at least some of the time, you're trying to make a ball, a golf ball, baseball, whatever it is, trying to make it go as fast as possible. And to do that, you have to do two things. You have to first maximize the force. In other words, swing as hard as you can, throw as hard as you can, kick as hard as you can. But the second part of that is follow through, which is maximizing the time. So remember, impulse is force times time down here at the bottom. If you can increase the force and increase the time, you will increase the momentum change, and that'll give you the biggest change in velocity. So increasing the force and increasing the time. Follow through, like if you look at this picture of Tiger Woods, he's just got done teeing off, and he's following through, and you can tell because his club is almost wrapped all the way around his body. Well, what he's doing when he follows through is maximize the time that the club is in contact with the golf ball. And so following through is important for increasing that time. So increasing the time, increasing the force, both of those increase the momentum change, but also give us the biggest change in velocity, which is often what you want in sports, like in some of these examples here. You can probably think of, if you've played sports, you can think of when your coach has told you to follow through. The physics way of explaining that is by what you're doing is increasing the time. Okay, and then the second part, the second example that impulse is important is when we often try to minimize the effect of a force. So here's the example we use in a collision. Which would you rather hit? Let's say you were driving down the road on a bike and you had no brakes and you had to stop and you had to choose between hitting this concrete wall or hitting this giant haystack. Obviously we would choose to hit this because it would hurt less. And that's the obvious answer, but there's actually a good physics way of explaining that. And if you look down here at the bottom, it says both of them will stop you. The wall will stop you, and so will the haystack. So either way, the change in the momentum is the same. If you're driving down the road on a bike, you're moving, you need to stop. Both of these will stop you, so both of them will give you the same amount of impulse because both will stop you the same amount. So the change in momentum would be the same. But we would rather hit this haystack because it's softer. The physics way of explaining why it's softer is the force is less. So they don't have the same amount of force. This wall and this haystack do not have the same amount of force, but they do have the same amount of impulse. So read what it says here. The force of the haystack is less than the force on the wall. And that's good because the force is what you would feel when you hit it. You'd rather feel less force because it's less likely to break your bones or hurt you somehow. But the trade-off of that is the time part of it. the time is longer on a haystack. The time for the haystack is greater than the time for the wall. When you hit a haystack, it takes a longer time to stop than it does if you hit a wall. If you hit that wall, you're going to stop in a really small amount of time, and that corresponds to a really large force. But if you have a long amount of time, it corresponds to a smaller force. The same impulse is the product. The impulse is the product multiplying the force in time. So the impulse is the same for the brick wall and the haystack, but the forces and the times are not the same. So impact time is what's important in a collision if you're trying to minimize the effect of the force. If the time is long, the force will be small. Impact time by definition is the time it takes in a collision, the time it takes for your momentum to become zero, the time it takes to stop. And the force is how much force it takes to stop you. And this little picture over here, this is kind of a silly boxer. If you look here, the force, yeah, it's the change in momentum in both cases. What it's supposed to show here is that boxing glove is moving to the left, and the boxer being hit is also moving his body to the left. So he's trying to avoid getting hit as hard by moving the same direction as the punch. But this guy over here on this one is moving the opposite direction. It's like he's moving to the right while the boxing glove is moving to the left. Well, both of them will stop, but if you look, there's a small f on the left. On the left side, there's a small force and a large time. Well, a small force doesn't hurt as much, but it takes longer. On the right side, a large force is going to do more damage to the guy's face. You can see how his face has become concave, and it also means a smaller amount of time. Alright, so just as some other examples of ways that we use impulse to decrease the effect of a force by increasing the time are some features of cars that are built in, like the airbags and the dashboard and seat belts and all those things that give us give a car all those safety features in a car. Those things are important. But think about this right here. If you try to jump off a table or jump off somewhere high, when you land, you always bend your knees some because it makes your body's center of gravity slow down over a longer period of time instead of keeping them straight. If you keep your legs straight when you try to jump, you're gonna break something. You're gonna really hurt yourself. So anytime, all these are really examples of making the force smaller by making the time even longer. And look down in here, it says if you could increase the time of impact 100 times, if you could take 100 times longer to slow down, then the force of impact will be 100 times less. And that's kind of the idea behind vehicle crash safety. They're indirectly proportional, which just means that if one of them goes up, the other one will go down. Okay?